Our discussion so far has focused on the population mean, but many business, socioeconomic, and political matters are concerned with the population proportion. Analogous to our discussion concerning the mean, we also make inferences about the population proportion on the basis of sample data. Here, the relevant statistic or estimator is the sample proportion and is symbolized by the P capital bar. And its particular value or the estimate is symbolized as small p bar. The population proportion itself is symbolized by the small letter p without the bar. Now, let's start our discussion on sampling distribution of the sample proportion. The population proportion P is first introduced in the binomial distribution. The sampling distribution of P bar is closely related to the binomial distribution. So recall that the binomial distribution describes the number of success X in n trials of a Bernoulli process, where P is the probability of success, and thus P bar is equal to X, or the number of success, divided by the n, or the sample size. Analogous to deriving the sample distribution of the sample mean, we can derive the expected value and the variance of the sampling distribution of the sample proportion P bar as the expected of the sample proportion is just equal to the population proportion, which implies that the sample proportion is an unbiased estimator of the population proportion. And the variance of the sampling distribution of the sample proportion is just equal to P, the population proportion, times 1 minus P divided by n. So, analogous to our discussion in the last section, we refer to the standard deviation of the sample proportion as the standard error of the sample proportion, which is given by the following formula. We make statistical inferences about the population proportion only when the sampling distribution of sample proportion is approximately normal. Referring to the central limit theorem, we can conclude that the sampling distribution of sample proportion is approximately normally distributed when the sample size is sufficiently large. Or, as a general guideline, the normal distribution approximation is justified when n times p, or the number of the sample times the population proportion, is greater or equal to 5, and n times 1 minus p is greater or equal to 5. If the sample proportion is normal, we can transform it into the standard normal variable as given in the following formula. Therefore, any value of the sample proportion or the estimate has a corresponding value of z given by the following formula. Remember that capital P bar is the sample proportion or the estimator, and the small p bar is the estimate or the value of the estimator, and small p is the population proportion.